So duplicates are shown in this plot, the sequence duplication levels plot. And as you can see, FASTQC has flagged this plot as being bad, showing low quality. The criteria for warnings and failures are indicated here on the slide. So as you can see, he calls a failure because of this percentage here. So the percentage of reads that remain after you remove all the duplicate copies. So in this FASTQ file, 37% of the reads would remain after you remove the duplicate copies. The line that you see here shows the distribution of the duplicates. So how to interpret it? Along the x-axis, you have the duplication levels. So these reads occur only once in the FASTQ file. These reads occur more than 10,000 times in the FASTQ file. On the y-axis, you have the percentages. So in this FASTQ file, 30% of the reads occurs only once. Around 7% of the reads occurs twice, and so on. So this is an RNA-seq sample. So seeing high levels of duplicates is quite normal here. But he does call a failure, as you can see here, and that's just because the rule says that if the percentage of remaining reads after deduplication is below 50, he should call a failure. So for all RNA-seq libraries, FASTQC will call a failure, although it is quite normal in these libraries to have these high levels of duplication. So this percentage is of no concern. And the same is true here for the plot. So what you see here, reads that occur more than 10 times, more than 50 times, more than 100, more than 500 times, they are all reads that originate from these highly expressed genes. So it's normal that they are here. The only thing you really have to watch out for is here, the far right of the plot. When you do see a sharp peak here, so for the reads that occur more than 10,000 times in the FASTQ file, this peak often points to contamination. And this is not only true for the RNA-seq libraries, but also for DNA-seq libraries and for ChIP-seq libraries. So optical duplicates tend to appear in low copy numbers, so you typically find them here in the 2, 3, 4, 5 bin. PCR duplicates should also appear in low numbers, although it depends on the amount of PCR that was performed. So typically they occur also in the mid-range of the plot here, and on the far left you can find unique reads. And for DNA-seq libraries, this peak should be as high as possible because it will reflect a high library diversity and minimal duplication. So to interpret the plot here, you have to take into account the overall quality of the data. So if the quality plots, this one, and this one, show that the quality of the reads is low, this will have implications for the duplication levels. Because to find duplicates, FASTQC will look for reads with exactly the same sequence over the first 50 bases of the reads. And when the overall quality of the reads is low, there will be a lot of sequencing errors, so he will miss a lot of duplicates because of the sequencing errors. They will not be identical anymore, but there will be sequencing errors.